Uh, this session is related to planning experiment from 2019 session papers. So we have from March 2019, paper 6, variant 2. First experiment, student wants to investigate the effect of air resistance on swing of a pendulum. So we have to plan an experiment which enable us to determine how the air resistance changes the way in which the pendulum swings. We have a light wooden rod is there, as you can see, and there is a bob is attached approximately 80 centimeter long, and one end there is a hole. A piece of a modeling clay is there which act as a bob, and there is a sheet of a thick card which is will provide the air resistance when the pendulum swings. So thick card will be there, will attach to this clay so that it can experience the air resistance. So we can attach a card here. So in our plan, what we have to do, we have to list any additional apparatus because we want to investigate how the swing of a pendulum is affected by the air resistance. So swing of a pendulum, what parameter will measure? So mainly will measure a time period. So what apparatus we need for this? We need a stopwatch or a stop clock. Any additional apparatus, what we need a stopwatch here. Then explain how you would carry out your investigation and which measurements you should take. So which measurements we should take and how we should carry out this experiment. So we'll mark the mean and the extreme position, and then we'll release this pendulum and allow it to vibrate or a swing for example 20 oscillation or 15 oscillation, and then find the time for one oscillation. We'll repeat the experiment and how we can change the air resistance by changing the inclination of the card. So how air resistance can be changed? Like we will change the inclination of the card. As you can see, like we place a card here, then we slightly make it tilt or change the angle of this card where it is attached. So first example, the card goes with attached exactly vertical, then slightly tilted, then further tilt, because that will change the air resistance experienced by this. And we'll repeat the experiment with different orientation of the card. So whenever measuring a time period, we will always mark the fiducial points or the mean and extreme position. That is first thing. Then we will release the pendulum and place a card. With a clay. Then even it can be done with card and without card. Like example, first we did without card and then we'll do with card. That will also have air resistance. So we can, or this can also be done like without placing a card. Or first you place the card and record the time for 10 oscillations. And we'll find the time period, find the period of oscillation, and repeat the experiment. Without the card. Because if you repeat the experiment without the card, that will also change the air resistance. The next part, state the key variables. So we have to mention the key variables which we will control for this experiment. What we can control here, the length of the pendulum, the amplitude, the position where we release this, that should also be same. Then how would you use your reading to reach the conclusion? So how we'll use our reading to reach the conclusion? So we can plot a graph, or we can make a bar chart here between the time period and a bob with, like a pendulum without card and with card. And we'll compare the time periods. So on y-axis, we can have the time period. On x-axis, we have a sample. And we can roughly sketch here with air resistance and without air resistance. Here we have a time period. And this one is without air resistance. Other one is with air resistance. The tables which we will draw. So with a column heading, two tables will be there. First one is a time for 10 oscillation, which we call small t, and the second one is a time period, which is capital T. So small t is a time for 10 oscillation, capital T is a time here also. And this one is with, other one is without card. Basically, with card means with air resistance, without card means we assume there is no air resistance. So this is how we plan this experiment to find the time period, how the air resistance can affect the swing of a pendulum. The next experiment is from May-June 2019 session. In question 4, a student investigates the work required to pull a box of which contain a mass up a slope. We have to plan investigation how the work required to pull the box upon the slope depends on the mass. Work is calculated by the force and the distance moved in the direction. The following apparatus is available. We have to plan, we have a wooden board is there, a box is there, selection of masses there, meter rule, electronic. List any additional apparatus because we want to calculate work done. So we have the ruler, we can measure distance, but how to measure a force? The force can be measured by a spring balance, or we also call that as a force meter. Force meter or spring balance can be used to measure the force. Then explain how would you carry out investigation, include the measurement you will take. So how we carry out this experiment? First, what we will do, we will set up or place the apparatus as shown, like the setup. Then we will use a force meter and pull this box up, and we'll measure the distance which we move. And then we will repeat the experiment by adding more weight or more mass into the box. So we will attach a force meter here. Or a spring balance, and move the box to certain distance. And we will measure the force. and distance moved by ruler or a scale. Then we'll calculate the work done, which is equal to force into distance. Then we'll repeat the experiment with different loads by adding more load. Then the parameter which we will keep constant. So key variables, the distance moved for each box, the angle of inclination for this inclined surface, then draw a suitable table. So what table we can have? We can have force, we can have distance, like the mass is there, the force will be there, distance will be there, and the work done. And whenever you're making a table, it should be with the column heading. Like example, first we have a mass, normally in gram, and here you can mention repeat with different masses. Then we will have a force which we apply by in Newton, the distance moved in centimeter or a meter if you are taking. Then the work done will be new if force is in Newton and distance meter, so work done Newton meter or joules. We don't have to fill up this table, but table should always be with a column heading. Explain how would you use your result to reach a conclusion. So how we can, so whenever we want to reach a conclusion, we want to identify a relation between the quantities. So we can either plot a graph here, because we are finding how the work done is affected by the mass. So we should plot a graph, and always the independent variable on x-axis, because when we change the mass, the work done will change. So mass is independent and work done is dependent. So what we should do, we should plot a graph for mass on x-axis and work done on y-axis, because work done is an independent variable and the mass is a dependent variable. So this is how we plan this experiment to investigate how the work done is affected by the load or the mass present in an object. Then another experiment from this session, which is winter 19, October, November. A student is investigating a time for a metal ball to stop after being released on a curved track. Figure 4.1 shows the slope of a track, and track is flexible, so the slope of a curve can be changed. So we can change the slope. The following apparatus is available: a selection of a metal balls, different masses are there, a flexible track is there, clamp to hold the track, stopwatch is there, a tape measure, and a meter rule is also there. A student can also use other apparatuses in the material that are usually available in the school lab. We have to plan an experiment to investigate a factor that affects the time taken for a ball to stop moving after being released. So state how you would expect the ball to move. So what we expect the ball to move, we expect this ball, when we release the ball will roll down, move to opposite side, and then return back, and eventually it will complete vibrations and it will stop at the in position. This is what we expect. Explain how would you carry out the investigation, and so how we can carry out experiment, as they did not mention which variable we are investigating. So we can change any of the variable, like we can keep the height same. Either we can keep the vertical height same from the ball where the ball is released and change the type of the ball, or We can change the slope of this curved surface by making it more bent, and keeping the height same and the ball also same. But better, we can investigate any one of them. So what we expect in this experiment, the ball will vibrate or move to and fro, and eventually it will stop. So the ball will move to and fro, and eventually it will stop. Then, because we want to investigate how much time the ball will take to stop. So what we will do, we will release the ball from certain height. From the measured height, and start the timer or stopwatch, and stop the timer once, or when the ball completely stops. So this is how we investigate. Hit which variable you will keep constant and which variable you would change. So what variable we can keep constant? The constant variable, we can keep the height from which the ball is released. We can keep the slope of this cut surface constant, and we will change the mass or the type of the sphere. Then draw table or tables with a column heading, because we are investigating how the mass can affect the time taken for a ball to stop completely. So in one of the column, we will have mass, and we'll have a time taken by a ball to stop completely. Then explain how would you use your reading to reach a conclusion. So how we will use our reading to reach a conclusion. So we can plot a graph. On x-axis it should be an independent variable, because when we change the mass, the time will change. So mass will be independent and the time will be dependent. So plot a graph between time on x-axis, mass on x-axis and time on y-axis, and compare the result. So these are the experiment questions from 2019 session.